Hello guys, today I would like to show you some calculation techniques on summations. First, we're going to prove that for all alpha that belongs to complex numbers and for each family of complex numbers a sub 1 and so on, a sub n, the summation of k equals to 1 to n of alpha a sub k is equal to alpha multiplied by the summation of k equals to 1 to n of a sub k. So we write the first summation of alpha a sub k, k equals to 1 to n, is equal to alpha multiplied by a sub 1 plus alpha multiplied by a sub 2 plus and so on, alpha multiplied by a sub n. In this expression I can factor by alpha, and so I get alpha multiplied by the sum as a sub 1 plus a sub 2 plus and so on, a sub n. Secondly, it's not finished, excuse me, and here we get alpha multiplied by the summation of ak, k equals to 1 to n. Secondly, we're going to prove that for each family of complex numbers a sub 1 and so on, a sub n, and for each family of complex numbers b sub 1 and so on, b sub n, the summation of a sub k plus b sub k, k equals to 1 to n, is equal to the summation of ak plus the summation of b sub k, k equals to 1 to n. The proof: the summation of a sub k plus b sub k, k equals 1 to n, is equal to the sum of a sub 1 plus b sub 1 plus a sub 2 plus b sub 2 plus and so on, a sub n plus b sub n, is equal to, we can gather all the terms like a sub k, I get a sub 1 plus a sub 2 plus and so on, a sub n, plus b sub 1 plus b sub 2 plus and so on, b sub n, and I get then the summation of a sub k plus the summation of b sub k. Thirdly, we are going to prove that for each family of complex numbers a sub each ij that belongs to C I is moving from 1 to n and G is moving from 1 to n. The double summation of A sub aj when I is going from 1 to n and j is going from 1 to n is equal to the double summation of A sub ij, and we exchange the position of the index. So here j is going from 1 to n, I is going from 1 to n. And to prove this formula, it's very useful to range all the A sub aj in an array and to sum in two different ways all the complex numbers. That we are going to store all those A sub ij, here A sub 1, 1, A sub 2, 1, and so on, A sub n1. So here I is equal to 1, I is equal to 2, and so on. I is equal to n. Here in this column j is equal to 1. Then we have got here A sub 1, 2, A sub 2, 2, A sub n2, and so on until j is equal to n. We have got A sub 1n, A sub 2n, A sub nn. And we are going to sum all those complex numbers in two different ways. First, we are going to sum by line. When we sum by all those terms in the first line, we are going to get the summation of A sub 1, 1 plus A sub 1, 2, and so on. It's equal to the summation of A sub 1 j when j is going from 1 to n. When we sum all the terms of the second line, we obtain the summation of A2j when j is going from 1 to n. And when we sum all the terms of the last line, we get the summation of j equals to 1 to n of A n j. And in a second time, to sum all those complex numbers, we have got to sum all those summations. So when we sum all those summations, we get the sum when I is coming from 1 to n of the summation when j is going from 1 to n of A sub ij. And secondly, we are going to sum by column. So when we sum by column, the sum of all the terms of the first column is equal to the sum of the summation of A sub I1 when I is going from 1 to n. When we sum all the terms of the second column, we get the summation of a sub I2 when I is going from 1 to n, and so on. And when we sum the terms of the last column, we get the summation of a sub I n when I is going from 1 to n. And then, to sum all the terms of the array, we have got to sum those n summations, and when we sum the summations, we get, here it's a sub I j, I is going from 1 to n, and j is going from 1 to n. So we have calculate the sum of all those numbers in two different ways, by line or by column, and we get the same expression. So this double summation is equal to this double summation. Bye bye.